Okay, yeah. So this Friday, I'll release the midterm right after class, and then you'll have all weekend and up till Monday at noon to turn it in. So I figure you should have time to at least enjoy one of the days on the weekend. And um, so the struggle as a teacher is trying to write an exam that is of the appropriate challenge. So it has to be challenging enough to kind of differentiate between students, but not so challenging that it doesn't differentiate between students because everyone does so poorly. So, I'm trying to find the sweet spot, and then yeah. And for the midterm, we're going to do something a little different. You're going to I'm gonna have you submit multiple files. So you're gonna submit the I'll talk about it on Friday, but you're gonna render it into HTML, submit the HTML file, but then I'll also ask you to submit the raw markdown file as well, and possibly other stuff. So I'll probably put in a question related to this blackjack simulation that we've been talking about this week. I'll probably have you modify the code for some of the parts, and yeah. So, but yeah, I'm still writing it. I give myself until Friday when I release it to keep making edits to the midterm. But we'll worry about that when that day comes. Let's see here. So on Friday we talked about simulating blackjack. So the key things that you should remember is that we have created a new class of object called hand, okay? And this class of object is a list, okay? So anything with the class hand is a list, and there are 3 things in the list: the size of the bet, the shoe, which is a function for dealing new cards. So within the hand, we keep information about how to draw new cards. And right now, drawing new cards comes from just basically a random card generator. We've created a way to generate new cards, with replacement. So every single time you draw a card, you have a 1 in 4 chance. A 4 out of 13 chance in drawing a 10, and a 1 in 13 chance of drawing an ace every single time you draw a card. Okay, so and then we keep track of the cards that we have in our hand. So this is it's a list of class hand, and by making it class hand, we can create its own method, which prints out the hand in its special format. Okay, and then we just began to create functions for the actions you can take. You can choose to hit, which increases 1 card to the cards in your hand, and you can stand, which just returns the hand. Okay, and now that we have these functions, we can start to simulate games. Okay, now so there's a few things we can do. We can implement a strategy for playing, but we can also create a way to just kind of prompt the user as if it were an interactive thing. We can prompt the user for what action the user wants to take. Oh, I'm sorry. We have to implement one more action that you can do, and that's double down. Okay. And so what happens when you double down? So in blackjack, when you double down, if you currently have 10, you've got to put down another 10. So you're doubling your bet. You take 1 more card, and you stand. Okay, so you double down, you double your bet, draw 1 more card, and then after that you're not allowed to draw any more cards. That's doubling down. Okay, so for that we're going to do function. We take our hand as the thing that we're going to modify, and what we do is we change the bet. Oops. And we say we're going to take our bet and multiply it by 2. And then we're going to take our hand, our current hand, and we hit that hand. And then we stand, which basically means return the hand, or we can say stand, which does that, okay? And then we can also split. We're going to do split pair. Okay, and so here when you split a pair is you take a pair of cards, and then so if you have say 2 8s, you split them, and then you'll have what that requires you to do is then you have to now you have 2 hands to bet on, and they play independently. So you now have an 8 by itself, and then the dealer will deal another card over here. You have an 8 by itself over here, and the dealer deals another card over here. And depending on the casino, sometimes they say after you split it, you get 1 more card, and then that's it. Or after you split, they're like getting dealt new hands, and you can continue hitting and things like that. So for now, we're just going to say there are 2 new hands, and you can hit on them and whatnot. But if we needed to, we could change the code to say after you split, you get dealt 1 more hand, or 1 more card, and then that's it. So splitting the pair is another function of our hand. Okay, and what do? We have to take the first card and create a new hand based on it, and then we're going to take the second card and create a new hand based on it. Okay, so we're going to so do you remember our new hand function? So the new hand function requires that we supply it a shoe, some cards, and a bet. Okay, so we're going to create basically we're going to create a list of 2 new hands. So I'm going to create list, and I'm going to do parentheses. All right, and in this list we get 1 new hand. Okay, so this is, we're calling the function new hand, and the function new hands requires that we supply it a shoe. All right, and so the shoe that we're going to supply it is the shoe that currently exists in our hand. Okay, so maybe I'll write, so create a list of 2 new hands. Okay, each hand requires the shoe, so we're going to give it the shoe that currently exists in our hand, and then the cards in new hand is going to be what? It's going to be the first card in our hand, and then we're going to call the shoe to draw 1 more card, right? So we're going to say hands $shoe, and we're going to ask it draw one more card. Okay, and then we say the bet is the current bet that exists in our hand. Okay, so that is 1 new hand, and pretty much the second new hand is exactly the same, right? And the only difference here is that instead of taking, oops, why did it do that? Don't auto indent like this. The only difference here is that instead of the first card in our hand, we're taking the second card in our hand. So, but everything else is the same. So we create a list with 2 calls to the new hand object. and it's complaining that I've done something wrong. Did I do something wrong? Cards. Oh, I didn't close this off. Okay, so hands $sign shoe, so that closes that off. Bet closes that thing off. Okay, I have to close this one off. And that closes that off. That closes that off, and that closes that off. This should be correct, but I might have made a mistake.
S missing.
There's an S missing? In cards? No, I think it's okay. Well, we can try it. So we have, so here I'll let me clear everything I've got here. I'm gonna run all of this. Okay, so right now all I have is a bunch of functions. All right, and so we can do something like, we're gonna create an object myHand, which is gonna be a call to new hand. With a bet of 1, I'm sorry, the shoe is the shoe, and the cards will be, well, we'll just have the default cards, and we'll say, so we'll actually, we can just take the default settings, all right? So we can ask, what is my hand right now? It's 10-10, so let's try split pair. Right now, we don't have any checks to make sure it's a pair. Okay, let's see. Oh, hands. Okay, yeah, that will mess it up. Do I have it more than once? Oh, I do. Okay, yeah. Thank you. All right, so now that we have this, let's try that again. So my hand is currently this. We'll call split pair on my hand. Okay. And look at that. I just drew more 10. Oh, and I got bets, B-E-T-S. Okay, so this is no good here. Okay, so now let's try that. Just make sure this this works. Okay, so that looks about right. I can keep splitting my hand, seeing what I get. Okay, so this that seems to be working fine. Let's see if we can double down my hand, which is a terrible idea since I've got 22. Oh my gosh, I pulled an ace. Wow. Okay, but if I did that again, yeah, I bust. Okay, so this is like the worst strategy, but somehow it worked. Okay. And otherwise, if I just hit my hand, yeah, the game is not 30, so so there I would have lost. Okay, so our functions seem to be working. We can always improve our functions by building in these checks to make sure we're not cheating, where we would be splitting something up. So we can manually play a game. Okay, so I'm going to just call this manual gameplay. And then just so so we have something. So we're going to just do set seed, not set underscore seed, set dot seed. Okay. And we can do dealer is going to be a new hand. Oops. Calling to the shoe, and player will also be new hand calling from the shoe. Yeah. So we can, and then we can just ask, what is the dealer card, the first dealer card? Okay, so the dealer shows an ace. This is bad news for us. And we can ask what our current hand is, and we show 13. So we'll probably want to hit, right? So we're going to do hit player. Okay, and then now we can call our hand. Okay, and we bust. So this is unfortunate. And then so now we can ask, well, what did the dealer have? And the dealer had 18. And then we can ask winnings, dealer. Oh wait, how is our winnings calculated? I forget. Winnings. Where's my winnings function? Winnings, dealer and player. Okay. So then we ask winnings, dealer and player. Cannot be a type double. What did I do? Oh, I have to do dealer $ cards. I'm sorry. And player $ cards. Ooh, I'm doing something wrong. Oh, I have to do hand value. All of this nonsense. Okay. Hand value dealer cards and hand value. This is like a terrible way to play the game. Okay, and all of that to say you lost. Okay, but you know, this is manual gameplay. You know, I can say I can comment this, right? Set seed, and this is deal cards. Here, see one of dealer's cards. Okay, see your own hand. Take action. Check. And in this case, we lost. See dealer. Calculate winnings. Okay. All right. So that's fine and all, but this would not be. So this is a simulation of blackjack. Okay, but this would be a terrible way to kind of. Nobody wants to have to type this out just to simulate one game of blackjack, right? So so we can kind of build a function to do all of this. Okay, and so. We're going to implement dealer's rules for drawing cards, okay? And so in blackjack, the way the dealer works is that the dealer has to keep drawing cards until the dealer reaches 17, okay? When the dealer reaches 17, it stops, okay? So at 16, the dealer has to draw another card. At 17 or higher, the dealer stops drawing cards. And that's it. That's the game. So I'll just write that. Dealer keeps drawing cards until dealer value reaches 17. Okay, at 17, dealer stops drawing cards. Okay, so we're going to write a function called dealer cards, and this is a function of the shoe. Okay, and all we're going to do is first we're going to take 2 cards from the shoe. And then now we're going to keep drawing cards from the shoe until we reach 17. So we're going to say while hand value of cards is less than 17 and hand value of the cards has to be greater than 0, right? Because if the dealer busts, the hand value of the cards becomes 0, so we don't want that. So while this is the case, what we're going to do is we're going to keep drawing cards. We're going to do cards is going to be, we're going to take our current cards and we're going to call the shoe and draw 1 card from the shoe. Okay, and then when it's done, we ask for our cards back.
You have like a capital letter in the second instance of cards.
Oh yeah, thank you. Thank you. Yeah, there's a nice little thing in RStudio is like if you highlight a word, you can see where that highlight matches. I don't know if you like the little gray boxes around, so you can kind of just make sure that you know, you're being consistent. So it helps. Okay. All right, so we can use this, and we can try just asking for dealer underscore cards, and we'll just give it the shoe. Oops. Okay, and it says, okay, we drew 810. And here, you know, it keeps drawing 974. Oops. Okay, so it seems to be working, and then, you know, here it bust because it 12, and then it drew another card, and then it bust. Okay. So then what we can do is we can, I'm going to implement a way to, well, here, we'll implement a way to prompt user for input. Okay, so let me just check, how did I do this? We're going to take our cards, and we're going to take, okay, and so this will be, I'm going to write a function. So this is not something that the is in the handout, but we're going to ask the prompt user, and this is going to be a function, and it's going to be a function of our current cards and the dealer card, or maybe I'll call it the face-up card. Okay, and so all this is it's going to just print out what the dealer has. So we'll start off with a new line, and we'll say dealer has colon, and we're going to write face-up card. Just make sure I'm doing this right. Yep. Okay, and then we'll do you have, oops. And then we're gonna paste our cards, which is cards, and our separator is the dash. Space, and we'll write value is equal to hand value cards. /n, and then we'll ask, so we're going to do read line, which prompts the user for input. Okay, what action would you take, or will you take? And it can be hit, stand, double down, or split. Okay, and what I'm going to do is, because it's expecting a capital, we're going to just say to upper, whatever we do here. Okay, and that's the last thing. And so basically, prompt user, we have this, and so we can just do something like this. We can say prompt, here, let me do, what's my hand? So my hand is 1010, so I can do prompt underscore user. I guess I should write this out here. Prompt user, and we're going to take my hand and just the cards, and we'll just give the dealer, I don't know, a 5. Okay, and we'll just try this out. Whoops. Okay, so it says dealer has 5, you have 10 dash, what did I do? Did I do this wrong? Paste cards, oh, I have to do collapse equals dash, I'm sorry. Let's try this. Why is this not working? Paste. Sorry. You have paste cards, collapse this. Am I leaving off a parenthesis somewhere? Oh yeah, that will do it. Okay. Now I have too many parentheses. Okay. Let's try this again. Shoot. Alright, let me just read through this. So function. That matches there. This matches that. That matches that. Paste cards. Collapse. Value. Hand value cards. Two upper read lines. Am I doing something funny here? My underscore hand cards. 10, 10. So it should print both of those. Okay, there we go. So what action will you take? Hit, stand, double, okay, so I can just say S. Oh, I should put in a new line character, and then it returns that. Okay, so I'm going to do slash new line. Okay, one more time. What action will you take? So you know, I can say hit, and then it returns. It will return this. Okay, so this is all we want to do, and so now we can build a loop to, or not a loop, a function to play an actual hand. And so what this will do is shoe, and then we're going to write strategy. This is basically the action that we're taking. We're going to give it two hands. We can give it an existing hand, but we'll just make a call to the hand, new hand function for default. All right, and so we say the face-up card is equal to the dealer's cards. Oh, I'm sorry. Dealer is not new hand. Dealer is dealer cards. Let's just make sure this looks right. So we're going to go dealer, and we look at the first card in the dealer card. Okay, and then so now we're going to just say the action that we take is our strategy. In our case, what we're going to give it is our cards, the same things that prompt user is asking. Okay, so when we say strategy, what we're giving it is prompt user. Okay, so we're going to say hands $ cards and the face up card. Okay, and so that that takes the this basically will prompt the user for what he wants to do, and then we say, okay, we're going to just keep doing this thing until either the action is stand or the cards bust. Okay, so we're going to say, while the action is not equal to stand, and the hand value is not equal to 0. Then keep running this series of actions. So basically take the action and modify the cards. So if the action is equal to hit, what do we want to do? We want to say hand is hit the hand. Okay, so we're going to just take our hand and we're going to hit the hand. And then we prompt it for action again. Okay, we're going to say action is why do I have another parentheses? Oh, how does this keep happening? Okay, so if it's not hit, then we do a else if. Oh, I gotta encompass these because I've got more than one thing going on here. Okay, so else if we say we're gonna do double down, then we're gonna hit the hand and then action will be equal to S. Oh, and this is actually double down on the hand. And else, then that means something. So right now we're not gonna implement the split just yet. Okay. So then we'll if something else happens here, we're gonna say stop. And we're gonna say unknown action should be either S, H, D, or SP, but we haven't implemented the split yet. Okay, but we can try this out, and then at the end of all of this looping business, we're gonna return the winnings of hand value of the dealer and based on the hand value of our current hand. Okay, times our bet. Okay, and I think this will work. I hope. Okay, so we're gonna try playing a hand. I'm gonna say, all right, so we're gonna do play hand, and we're gonna give it the shoe. Our strategy will be prompt user, and that's it, because it defaults to everything else. Ah, of course, this nonsense. I have hand. I keep wanting to write hands, huh? Okay, so I should just double check, make sure I've got hand everywhere. I have hands there. Okay, so card, hand. Okay, we'll try this again. Okay, so we do this, and it says dealer has 2. You have 8, 7, 15. 8, 7, which is worth 15. So what do? We're gonna stand. And it says we won. Okay. Now this is not exciting because it just says it doesn't tell you what the dealer had. So you have 18. So we'll also stand again. And here we lost. Okay. So perhaps before it just prints the winnings, we'll ask it to print dealer cards. I'm gonna paste our dealer cards. except we want dealer, not cards. Okay. Paste dealer, hand value dealer. Okay, so we're going to try this again. So we can try play hand. Okay. So the dealer has 7, you have 16. What do you think we should do? Hit or stand? Dealer. All right, we're going to risk it. We'll hit. Okay. Oh, what just happened? Value 0, what action? If it says 0, it's supposed to stop, right? So I must have done something wrong. While action is not 0, hand value of cards is not equal to 0.
Oh, is it because the double ampersand, it'll only evaluate the first one?
No, this just means only do it once, but let me just... oh, I guess this means I should just stand. Okay, so let's see. Dealer 7, but we still lose because we busted. Let me just see. So what I need to have in here is, and under prompt user, I need to say if hand value of cards is equal to 0, then return S. Okay. Otherwise we're good. So we can try this again. Okay, so we can try hitting. So then, no, it's still asking me for action. Okay, well, it's not working the way I expected.
I think it is still executing the line below the S,
Or
right?
am I
Just tell it to stop.
So I have to do return this, and then that will stop it. Okay, let's try it one more time. So we'll just keep hitting. Okay, so then it killed me. Okay, so then so I should say dealer cards are this, and then I should have player cards. You have this. All right, I think this will work now. You have, so we're gonna do hand $ cards. Okay. So all of this. Okay, so dealer has 10, we're gonna just see if this works. So you bust, and there you go. Okay, dealer has this, we're gonna stand, and we win. Okay, so this is very exciting, but and there you go. Okay, so there is a blackjack simulation that constantly prompts the user for what action to take. Maybe we don't want to do that. We can implement, instead of continually asking the user what to do, we can implement a simple strategy instead. Okay, and so we're going to call this simple strategy. And this will just be, all we're going to do is we're going to return either S or H or D or split or something, okay? And so a simple strategy that a lot of times people will use is if you have less than 16 and the dealer has 7 or more, or if you have less than 17 and the dealer has a 7 or more, then hit. Otherwise, stand, okay? So if the dealer only has so if you have like 13, but the dealer only has shows a 2 or something, or a 5, then the strategy might just be to stand, so you don't go over 21. Okay, so we're going to say if hand value of your cards so we'll say cards is under 17 and the dealer face up card. So actually, because we want it to process the ace as seeing an 11, so we're going to put it into hand value of the card. Face up card is over 6, so 7 or more. Okay. Then what we want it to return is return a hit, otherwise return stand. Okay, so this is just a simple strategy, and we can try this out now. Okay, so we're gonna play a hand, but instead of prompting the user, we're gonna use our simple strategy, and I hope this works. Okay, so what did this do? The dealer has 21.5, which we were going to lose anyway, but we would have seen the 10. So we saw 5, 7, we have 12. We see the 10, so we say we hit. We get 17, so we stand, but we lose. But that seems to be our simple strategy working. We try again. So here we see the dealer have 5. We have 8, 6, which is less than 17, but because the dealer has less than a 7 here, we stand, and so we stop. We have 14, and the dealer keeps hitting and loses, so we win. Okay, dealer cards, we see the 8. We have a total of 20, so we stop. The dealer keeps drawing until 20, so we push there. And we see the 8. We have 17, so we stop. Dealer busts. So this seems to be working, our simple strategy, okay? In that it just returns hit and stand. And so with this, we can replicate this. Okay, so we can just do replicate, and we can play 5 games of this. Okay, and so here we can see it play through 5 games here. And it says, you know, you won this one, you pushed here, you won here, you won here, and then you lost this one. Okay, and so your winnings are 1, 0, 1, 1, -1. Okay, so we won 2 out of, or we were up $2 after 5 games here. And so, you know, we can comment this out so it doesn't print every single time. Okay, and just keep track of the winnings, and then we can play this game like 1,000 times and just see how often we win. So we can do replicate 1,000 games of our simple strategy. You don't want to do this with prompt user because that would be unfortunate. Okay, and then we'll just say wins. We'll keep track of this. Okay, so it did it, and then let's see. So after playing 1,000 games, what happened? Wins is a large list of 1,000 elements. Okay, something happened here. Oh, it's dummy. Of course, that's not going to work. We have to replicate not the simple strategy, we have to replicate playing the hand with the simple strategy. Okay, this will make it work better. Okay, so now that works. Okay, now we can ask, you know, what happened the first game, and we can ask what happened after 1,000 plays. we're down 62 bucks, okay? But that's expected, right? Like if you play 1,000 games of blackjack, you should be happy that you only lost $62, okay? Using your simple strategy. And you could see, well, did I get any more lucky? And you can do sum of wins. Okay, that time we lost 92. And then so, we can do this over and over again. And we can actually replicate this in of itself. So I think I can replicate this summing thing even, so we can try this 50 times and just see what happens, okay? So we'll call this earnings. So actually I should have put this on another line. And we can say like, okay, if you go to Vegas and you play your simple strategy, 1,000 games, which is a lot of playing, but so we're going to replicate this 50 times, and we'll do a sum here. So it's running, okay, and then we can just check out all of our earnings. Okay, so I mean that's expected, right? So what's the mean of our earnings? This is after. So the average loss under the simple strategy is like negative 64 bucks or something, and so you can kind of simulate a whole bunch of these things, right? So just implementing our simple strategy, we see on average after playing 1,000 games, we're losing something around 67 bucks or something, and we can run even more simulations. Here I just did 50 for the sake of time, but I could do 500, and I don't have to play 1,000 games. I could play, I could just play 100 games and see how much we expect to win or lose in after 100 games. All right, so let's see. So mean earnings is okay. Wait, is that right? Oh, here I changed it. I left it 1,000 there. I'm like, what's going on? Okay, so if you play 100 games, your mean earnings, you're losing about $5 after 100, which sounds about right. We can, what's going on here? Why am I in insert mode? Okay, so yeah, play 100 games, you're losing about $5, $5 to $10. You might be unlucky and go down 30, or you might be lucky and come up 20 bucks ahead. So that happens. And so here's just kind of a taste on how we can start implementing this automated gameplay using a simple strategy. Okay, so on Wednesday we'll implement a more thorough method using a lookup table, and then we'll also start talking about counting cards and keeping track of things that way. Okay, and I'll post this code up on online for you guys to look.